Okay, good morning, everyone. So welcome back to RoboCup at Home Education Online Challenge 2020. Today we have an online classroom for open platform. And today we are the last online class for this open platform series. So we will talk about robot system integration. Similarly, have me, Jeffrey here, and also Jupyter Robots engineers, Wu and also Max and also David. Right, so today we will bring you the topic on application development and also competition development. Okay, next. Okay, so just I haven't done the sound check. So if let's say you can't hear me clearly or you can't really see the screen, please feedback in the group chat. Or if you have any question throughout this whole session, please also use the group chat windows to key in your anything that your inquiry or anything that you want to contact with us. Okay, so today arrangement, we will have the first hour to talk about application development. So I will summary what we have done in the previous classes. Then today, how to put all this lesson together in order for us to build a complete service robot. Then in the second half is more towards our online challenge, the competition. So I will explain a little bit more about the procedure, about how are you going to develop for the competition, and also how are you going to submit all the necessary documents and also materials in order for the technical video challenge and so on. And also, at the same time, we will invite Jupyter robot engineers to explain to you how are they going to support us in terms of the robot development, particularly in, for example, those teams that without robots, you can actually get helps from Jupyter robots to help to execute your code in their robots and also for the video to be taken. Okay, so that is something that we have arranged today that later on, Jupyter Robot will tell you more about the details. And as usual, we have the Zoom link over there. So please pass this link to your colleague or friends or your student, whoever that not yet come in, right? Then at the same time, we are live on Facebook also. So maybe some of you are over there in Facebook. So please be aware about this broadcast. So please be careful on your privacy, not to review yourself for your sensitive personal information. Okay, and for the rest of the thing, for example, like the slides that you see today, as usual, is posted on the website. So you can hit to our website for the competition detail and also our classroom materials, particularly the slides. So you can get all this material over there. Okay, so I have tell you all the arrangement. So let's get started. Next. Right, so a brief review on the previous class. So last week we have done robot navigation. So I mentioned about how you can build the map, SLAM, using the Gmapping. Then once you got the map, you can define a few waypoints in order for you to give the instruction for the robots to move from point A to point B, and so on. You can have more points. And the robot will autonomously move from point A to point B, and in the middle, it's able to avoid obstacle automatically. Okay, then after that, it will redo the path planning and move towards the goal. And we have shown you both in simulation, which is in Gazebo, and also in real robot. So Jupyter Robot have provided the exact one-to-one scale simulation model, the model in Gazebo, so that you can work on simulation while the similar code can be ported to real robot pretty much directly, right? So everything is, even the coordinate and all the size of the furnitures and everything are correspondent to each other. So you can do the development at home even without robots. Okay. Then as an assignment, we try to combine with a speech interaction module, which is we introduced in the first technical session, technical module, which is class, the second class or the third class, right? So you are asked to do this assignment, which is you try to combine the speech and also the navigation so that you can have a more interactive robots that you can tell directly the robot or your virtual robot in the gazebo to go from any particular point to any other particular point with the coordinate, with the name of the place that associate to the coordinate that you define in your code. So that is the assignment. So from there, you basically have done a system that able to move around based on your verbal instruction. Okay, so later on, I will revise again on the previous classes and give you some idea how are we going to put all this module together in order to come out with, to develop with a more complete service robot application. Okay, so that is something that I'm going to do it after this. Right, next. Okay, so as usual, for today's class, we also designed that you can follow everything just with your laptop. And by now, if you have followed all the previous classes, you should have all the speech, visual perception, navigation module already set up in your laptop. Okay, so I believe that if you have gone through the module, you already have all these things set up with all the assignment and everything, the code, and also like you have downloaded our example. So just in case that you haven't gone through like part of it or you miss some of the classes, as long as you have the virtual box image from Jupyter Robot, basically all this, for example, the base Ubuntu OS, the ROS system, and also all the speech visual navigation module already installed and configure, well configured for you. Right. So just in case that you missed some class or you haven't done the assignment previously, so don't worry. You're still able to follow this class by having the VirtualBox image that you can set up. So how to set up, just in case that you need to reset up, you just need to go to the first technical class. The instruction is over there. You can see the videos and also the slides on our website. So just set up that VirtualBox image. You will have everything available for you, including our example from GitHub. So just in case that you're not sure where is it, so we have all the example, including all the module. We have all the example, including like the example that we are going to talk about, the integrated application that I'm going to explain to you later. So please at least get ready, download the example into your laptop so that you can follow us during this class. And the last module for the ARM is optional. I put it optional. The reason is because due to the time constraint, the design of this course, and also due to the complexity, we have take out this ARM module and replace with today content, which is more focused on how you want to put them together and also how to prepare for the competition. And I think we think that this arrangement will be more beneficial for you, with the reason that the ARM might not play a very big part in the competition preparation. I will explain more when I tell you more about the competition preparation of this. Right, so don't worry about the ARM module for the time being. It is optional, but of course you have extra time. Our materials and also example is over there for you to explore. Right, okay, so these are all the preparation that you need in order to follow this class. All right, can I have next slide, please? Okay, so the arrangement for today is for the first half, I will explain about the application development, which is more like I will mention about the summary of the previous classes, then how to put all this lesson together for system integration, right? So in order to explain the system integration, I will use two example, which is the source code already are available in our repository. So if you download the Learn ROS repository, you already have these two examples inside there. So you can explore them later on. But I will use these two. One is the first one is the people tracking, the follow me example. And then the second one is a more integrated one, which is it contains almost all the modules that we have done in the previous class into a single application example. So I'll use this example to explain to you like how I put those things together, and you can use this as a template for you to develop your own service robot application. Okay, so this is the content for the first half. And for the second half, I will start to explain about the competition development, which is more, I will give up the exact example that we have done previously in RoboCup at home competition. So first, I will explain the rules, okay, for this time, for this online challenge 2020, by telling you like what are the expectation, the requirement, and also what are the things that you need to prepare in order to join the competition. Then I will use the example of from Robo 2018 with the reason that because I can't tell you exactly how you are going to do for the competition this year, because that is supposed to be a competition. So it's for you to figure it out, but I will use the example last year, although it's written there 2018, but I'll explain to you why it's 18, it's not 19. I will use that example to tell you exactly how or what had happened, okay, for the teams that develop for the competition and how they prepare the details. I will tell you like exactly how they do the thing, so that you can have a reference for you to do your development for this year competition. And other than the tasks, I mean the competition tasks, we also have the teams that you can do open challenge, which is you can have open teams for development, which I will explain more later on, following the rules. And lastly, we have the teams that to address the current issue on COVID-19 pandemic. So I'll show you some example, what are the things that possible for you to develop if you prefer to go for this team. Okay, next, please. Right, so I will start with the summary of previous classes. So we have 4 classes before this, which is we start with the system robot development system, which is you set up the virtual machine. Yes, the virtual machine, the virtual box image. Or if you would like to install the ROS Ubuntu system by yourself, yes, we have the guide in our slides as well, and all the modules that you need. Then I have introduced you about the ROS basic. So what is ROS and the basic concept of node topics and so on in the ROS basics. Then a very important part of ROS, which is the publisher and subscriber. So this is the communication protocol that basically you will use almost 60 to 80% of your development after this, right? So that is the first class, so that you know how to start your development. And with all the associate hardware that you need, right? So you understand that. But on the second class, third class, and fourth class, so I divided the class into these 3 different modules. So the first one is about speech interaction, where you do your speech synthesis and also recognition. So you try to make your machine or your robot able to speak. The first thing is able to say something based on the string or the sentences that you input. So the robot able to convert this information into voice information, which is it will tell, it will speak out the sentences using the speech synthesis module. Then not just able to speak, but also able to listen. So we have the speech recognition. So how to recognize the input verbal input from the user so that the robot able to respond. And with this recognition and synthesis, your robot able to do natural language interaction with the user. So with this module, you can have your speech interface for your system, whether it's a robot or machines or anything that you will want to have the interactive ability with the user. Okay, so that is the first part. Right. Then the second part is about the RGB sensing, how you acquire particular image data. Then you do some image processing. Then the third one is about the SLAM, which is your robot able to scan around, get the information, the distant information, so that it can build a map. Then after that, you do the autonomous navigation, which is you move from point A to point B. And we have done this both in simulation and also in real world. Okay, so I will start one by one to tell you about the detail and how are we going to put them together. Right, so next class, next please. So the first thing, ROS development system. So if you try to reflect back what we have done, the very important things over here that you have to remember or you have to get familiar with is the concept of ROS, which is very different from maybe your previous development in C or any system other than ROS, okay, that you have attempted. So in ROS, you need to understand the distributed node and topic concept. Then you need to understand how to link these two together. So how to make all the nodes to talk to each other by using the publish and subscribe. Okay, so I can tell you that maybe 60 to 80% of your development will be using just this publish and subscribe. Later on, when you look at the example, you will see like most of the cases, what you need to do is try to link all the different nodes together so that they can function following the logic or the sequence that you want. Okay, so the publisher will will publish message, and the subscriber will subscribe this topic in order to get the data, and this is how the data flow between nodes in ROS. So the module the modules are comprised of several nodes, and another module also comprised of several nodes. So what you need to do in order to combine two features or two modules together is to make this node able to talk to each other. Okay, so that is the class for robot development system. Next. Then we have the speech interaction. So just now I mentioned about the speech synthesis and also recognition. So that is how you make the robot able to respond or interact with your user. But if you look at this diagram, it is not just as simple as synthesis and recognition, because we have other things. For example, we have speech understanding and dialogue manager. Over here, we skip the sound detection and localization because that one needs special hardware. For example, you need to have your mic array in order to do that. So we just skip that part. But for speech understanding and dialogue manager, that is something that you still need to have in order for your robot able to respond. But it can be done as simple as using if-else case, that you try to write down a lot of if case if you detect certain keyword. So in the example, I still remember I give you the assignment that asks the system to recognize certain keyword from the user input, so that you can guess what will be the possible question. So this example will be demonstrated. Again, after this, we have an integrated example. So later on, David will show you this example. So we use the keyword spotting using the LM module. So we spot certain keyword, important keyword that represents certain question, and based on that, the robot will respond. But of course, you can have more sophisticated speech understanding and dialogue manager. For example, like you can, I think we introduced in our class. So instead of offline module, we can have the online module. like the Turing machine and so on. So you can have a lot of this dialog manager that can help you to do the response. And also we have one which is using the AIML engine that help you to have semi-automated speech understanding, also dialog manager. So which means like if you recognize certain pattern in your question, then you have the appropriate answer pair that prepared in your database in order for you to respond. So these are the things that we discussed in our speech class that you need to refresh back, try to review all these things so that you can build your speech interaction module for your robots. And this speech interaction features or function is the most fundamental and important in service robot application. So in almost all the service robot application, whether is the robot able to move or able to grab something or able to see something, the most fundamental one is it able to say something to the user and also respond. So one very good example that you can find in your daily life is, for example, your Siris or your Google Home or any smart speaker that available or speech interface that available in your car or in your phone and etc. So that is the first thing that you can put to make your system intelligent and to provide certain services. And that is the fundamental form of service robot. Okay, so this is the first module. So let's go to the second one. Next. So after your robot able to speak and also respond verbally, the next thing is we try to make your robot able to see the surrounding, see what happened in the environment that will be very useful for the robot in order to provide some services. So the first thing is I introduce you about the RGBD sensor. Okay, so how a robot able to get the information about the distance from the robots to the surrounding, and this distant information is very important, particularly for navigation, right? So we use the RGBD, the D part, in order for you to do the navigation so that your robot able to move around. And on top of that, we have the RGB, which is the color information. So the color information is something that you can do a lot of image processing after this. So the image processing part is a very big part because that actually can give you a lot of function. As you can see nowadays in your phone apps, you have a lot of apps are based on image processing. Whether your cameras apps that comes with various filters, your chatting apps that come with various effects and so on. So these are all the apps that use this image processing technique in order to create those kind of application. So we understand that in image processing, computer, digital image processing is a very big domain. So in the class, we show you some simple example that using the OpenCV library. So we show you how to do the face recognition. First, we detect the face. So from a frame, so we detect how many faces are there in the photo. Then after that, we do the recognition by giving the training. So you capture a few of the similar face as a database, and the OpenCV will have the algorithm in order to learn it and also able to recognize different faces so that you know you can label a particular face with a name. Then in the recognition phase, the system able to tell you exactly who appeared in the frame. Okay, so these features are very popular. Face, whether it's face recognition, face detection, or people detection, these are very popular functionality that we use in at-home competition. And you can use this, you can leverage the OpenCV library in order to create more application after this. Okay, so we show you the fundamental thing and also the infrastructure, the platform that you can add in. So if you want to have more, so you can like extend to more, for example, like cloud-based API, whether the Google image API and so on, you can extend that in order to have more image processing application. For example, like if you tap on Google API, so maybe it can give you more features. For example, not just the face, but also like the appearance. So what is this? Is this some disturbance from outside? Okay, never mind. Right, so we have killed it. Right, so sorry for that. So let's come back. Okay, so for the visual, we try to, so we have given you the platform so that you can add in more module or more example. Because I understand that if you are using ROS to do image processing, there are actually many resources and also example available in the net that you can port in or integrate it quite easily. Especially if you are using, for example, like the example that I've given to you in OpenCV, they are more on C++. So if, let's say, you are more familiar or you feel more comfortable with Python code, you can actually find the equivalent Python code on the net easily. The OpenCV, for example, face recognition by cascaded filter, Python code, you can get a lot and a lot of version, and even like some with extra features and so on. You can do that. And then to port in, you just need to put in and you just write into the ROS. You don't even need to write in the ROS format because you can run Python code parallel, and all you need to do is just to make the communication, whether it's in the ROS way, which is you use the publish subscribe, or you can use the socket in a more general way. So all you need is just to pass the message or pass the result that I show in the class, how you execute the example and tap in the result so that you can use it for your application. And with ROS, you can easily connect with other modules. So that is what you can do with our system. Okay, so that is about the speech. Okay, let's go to the next one. Okay, so in the next class, after the visual perception is the robot navigation. So robot navigation is we learn how to make the robot able to move autonomously within a 3D space and environment. Okay, but over here we assume our environment is 2D. I mean, like flat. So it just moves. You just need to concern about the X and Y, not the Z. So your robot is not going to fly. Okay, so for this 2D navigation, I've shown you in the class about how to build the map using the G-mapping tools, and also the autonomous navigation, which is you move from point A to point B by using the map. And all these things you have learned to do the development using the Gazebo environment, which is the simulator in ROS that give you the 3D model and also the 3D model of your robots, so you can see how the robot is able to move within this virtual environment. And also we built a map in this environment. But in the navigation class, we also show you that by using the model provided by Jupyter Robot, you're able to port your development into the real robot to run in the real environment, because we have the model that model exactly with a real environment. So we have that the experiment environment in Jupyter Robot Office. So we have that exactly, and Jupyter Robot has prepared the model one-to-one scale that you can do your development in Gazebo, so that later on when you port from your Gazebo development to real world, it matches. I mean, the robot will behave almost exactly the same. So that will actually help you a lot if you want to create the real application without the robots. Okay, then you want to combine this together with the rest. For example, like in the assignment, we try to combine the speech and also the navigation. So what we can do is you can use your voice, speak to your mic, so that your system able to recognize what you say. For example, like you ask the robot go to the kitchen, or you ask the robot go to the living room, or any particular place. And in your code, what you do is like you prepare the map. And when you prepare the map, you also try to get the waypoint, the point that you want for the robot to go around, which is a few key location that you know that will be useful for the robots to move around. Particularly in competition, in RoboCup competition, by my experience, is like you will use all this, what we call the waypoint, in order to instruct or give the instruction for the robots to perform certain tasks, because certain tasks happen in this key location. For example, like you want to find a good location for the robot to stop if in the kitchen, when you ask the robot to move to the kitchen. Or you might want to have a few points that, for example, in front of the cabinet, because like you might ask the robot to find something on the cabinet to get something, or in front of the table, because they might have some tasks that require the robots to do some operation on the table, in front of the table. So the robot have to stand in front of the table in order to do some operation. So these are a few key locations that you can identify in the phase when you develop your map. Okay, so you can put all these things together, then you integrate with your speech module, then you can have a very interactive robot that you can ask the robot to go to anywhere. So in the assignment, you are asked to put at least 3 points, but of course you can have more points as a waypoint. Then you can define them in the terms that the user can understand. Kitchen, toilet, all this in front of the table, and so on. So the user able to instruct the robot verbally. So it's in a natural interface for the robot to move around. So that is the basic navigation ability for the robots that you can achieve with our example. So it's just use our example code and integrate it with the speech interaction part, and then you can put these two together. Right, next. Okay, so you know all this module. So the next thing is like, how are we going to put all these things together and rearrange or assemble them into some meaningful application? So by now, the application is more complicated than the assignment, because the assignment is the direct usage of the module. But when I talk about application, it's something that you want to solve certain problem. For example, you want to build a robot in order to help in the library. For example, you want a librarian robot, or you want to build a robot to become a waiter in a restaurant. Okay, by taking orders, by serving the guests, guiding the guests to the table, guiding the guests to the registry or to the door, or so on. Or you want to have a robot that help you in your house, for example, to help the elderly, to take care of your children, and so on. So these are the applications that you want to create by assembling the building blocks that you have learned before. So I show you this slide is to show you that you can not, you not just need to think about the software, but you can also rearrange in terms of the hardware. Because this whole project actually originated from a moving platform, which is the Turtlebot 2. So the Turtlebot 2 just able to move around, and that's it, okay? They can do the map and move around. But when I first used this platform to enter at home, so I found that I need to add in a lot more module. For example, like I need to make this robot able to respond to me in speech. So I add in the speech module. Then I also need to make this robot able to see me, to understand the surrounding, to track people, to track, to find objects, and so on. So I add in the visual module. Then I need to make this robot able to get something. So I have the arm module, and so on. So it is something that I try to put on, assemble new module together. So it become eventually today we have all this module, and how are they going to work together, whether in hardware or in software, I already have a basic framework for you. So in the classes, that is the basic framework. But due to this special arrangement for the online challenge or the online classes, so I show you mostly on the software side. But in the hardware side, you can actually be creative and create your own hardware arrangement as well. And that is, I also need to remind you and explain again here is because the competition is called open platform. Open platform means you are free to use any robot and also free to develop your own version of robots that you want. And we really want to see your creativity, not just in terms of software, but also in terms of hardware as well, like where you place the arm, where you put the image sensor, where you place your mic and so on, and what kind of hardware that you use to put. All these things are very important because this hardware function will actually play a very important part to make sure that your functionality meet certain quality. For example, like you use a better mic, and your placement is correct, because like the placement of the mic is very critical in order to capture quality sound from the user. So these are all the things that I hope you can learn, and also you can like open up yourself to more hardware design as well. Okay, next. Right, so these are just a few examples that I show you that my team made for different event in 2015. So you can see that in different tasks. So why we build differently is because like for different tasks, we identify what are the requirements. Then we try to optimize the system based on the system design, the hardware design based on the task requirement. For example, like it is, you need the communication, or you need the perception, or you need the mobility, or you need the grabs or anything. So we can specify our arrangement based on the requirement of the particular task. Right, next. Yes, okay. But of course also, like I understand many audience or many students, they might come from, for example, like computer science, or they come from software development majors and so on, that which is they don't really want to play around or change much on the hardware. You can also have some standard configuration. So this was a prototype that I built 2 years back. So it's something that we integrate together nicely. And also eventually this design I discussed with Jupyter Robot, and somehow they come out their version of the Jupyter Robots that you can see, that you saw in the previous class that they use it for the experiment. So they are very much similar, but of course you can have your own versions and so on. But of course, like what we want to help you is like we have a standard platform, but not really force you to use this standard platform. Okay, so we have something like a reference platform that you can use it for your development. And this reference platform, we have all the modules that I explained, and the example is compatible with this. So you can use the example directly on this. And later on, I will show you one integrated example, which is the party board that run on this configuration, hardware configuration, that will give you the functionality that you need in your application, in your competition, right? But that one is not, that example is not direct to any competition task. It is more towards a general platform for service robot. Okay, so I will tell you more later on in the example. So next, please. Okay, then for this time, because I understand that many teams not able, or whether you don't have the robots or you're not able to access to your robot. Okay, probably. Okay, so in that, if you are in that situation that you're not able to access or you don't have the robots, don't worry, you still can develop for the competition. So it is similar to the one that I explained. the previous class that you can develop in a simulated environment, which is the gazebo, with the model that provided by Jupyter robots. So you can develop your robots to move around this environment, and then you can add with, for example, like speech recognition and also visual perception in real world. Okay, so you can act like, okay, now I'm in point A, so I do the interaction. Then after that, the robot's supposed to move to point B. Then the robot will move to point B in the virtual environment. Then after that, in point B, then you try to rearrange your environment, which is like, for example, like you have people that change, or you have a sofa, or then you can move your machine towards that arrangement so that you can continue the operation in point B. So you can use this arrangement to use whatever hardware that you have currently, which is your laptop with all the software and the devices for you to do the speech and visual. And then you combine with the one in Gazebo so that you can have the complete service robot development. Then if you have all these things work out on your own laptops with your own environment, then you can pass this work to Jupyter Robot to help you to execute the navigation part, which is they will put in their robots and do the navigation part. Then eventually you will have the video of all the parts in real world. So that is how, even without robots, you're still able to do the development for this technical challenge. I mean, technical video challenge, and also for the final. If let's say like you put your effort to create a very nice application. Okay, so over here, I would like to stress again that don't worry if you don't have your robots, and don't worry if you're not able to access to your robot due to the current situation. You can still do the development, and you can still do a very nice application with the resources that you have at home. Right, okay, next. Okay, so these are the resources that are already posted to you previously. What I want to mention here is more on the example. Okay, I've given you the Learn ROS repository in our GitHub, and inside there you have used the speech module, the vision, the navigation, the ARM. You can pass for this time because the ARM require whether the hardware or the virtual model in order for you to do the development. So we can just skip for this part, don't worry. But head to the APPS, which is the application. So that is the things that I'm going to explain to you after this. Right, so that is the things that you need to have a look now. Okay, next. Okay, so the first thing is in many of the, okay, so if I count back all the at-home competition in the past few years, almost every year they will have one task that will have a certain part in the task that require people tracking. So this is a very popular features that is required in at-home competition, right? So I will use this example. So in Turtlebot, we have a code or an example called the follower, the Turtlebot follower. Okay, so we use that Turtlebot follower, which is on the first link, you can find it. And in order to run it, you can run the bring up, the node, and everything. So you can make the Turtlebot detect someone in front and move around. So that is something that you can do. I'm not sure about in Gazebo, but I think maybe it can work as well, but I haven't tried that yet. Okay, but what I want to explain over here is how I integrate this part into a bigger application. For example, like in the 1 year, for example, Help Me Carry. Later on, I'll tell you about Help Me Carry. So in Help Me Carry, it's a task in at home that you need to ask the robot to follow in the first half of the competition. So the robot is supposed to follow someone, then reach a certain place, then it needs to stop and do other operations, for example, navigation and so on. So how are we going to integrate, do such integration? Okay, so that is something that I'm going to explain now. Okay, next slide. I'll explain how to do it. Okay, so in your example, so if you downloaded the example, you can see in the RC Home EDU apps, under that package, you can find this follower 2.launch. Okay, so I created this follower 2.launch is because I need to integrate that Turtlebot follower into real robots, which is the reference model that I show you. Okay, in that hardware, we require not just follower, but also we require some other thing. So which means we need to follow, and at the same time, we need to do navigation. Because in the task, the robot's supposed to follow someone to some place, then from that point, it needs to navigate back autonomously. So which means we need to have navigation, which is your autonomous navigation, that module, and your follower run at the same time because you have to update the map when you are doing your follower. So based on my experience, previously a lot of students actually come to me that they face a lot of difficulty in this because it might require two sensors. So one sensor is for the navigation, one sensor is for your follower because the follower is the visual perception to detect the person so that you can follow the robots. So they will have a lot of problems like how to set up. So I remember in the visual class, in the visual perception class, I show you an example that how to do multi-Astra, which is the Astra, the sensor that we use in our reference hardware. But if, for example, you are using other hardware or other sensors, you can refer to the framework how I make this tool, how to split the topic. So you have camera and camera topic, so how to split. So you can look at the example that how I do it. Basically, I define the driver, which is the Astra bring up. Then I define the topics that I want them to separate them. So I define one is the camera, which is the original one below, and another one will become camera top. So you have the image raw for camera top and image raw for camera. Then you can assign this separately, one to the follower and one to the navigation. So if you look at the code, you will figuring out how I do this. Okay, so you just need to follow the code that's given to you, right? Then when you look at the code, you understand like how you define the ID and so on. Okay, so that is the first thing. Then the second thing is you want to add in the voice as well, right? As a control, because in at-home competition, you are not supposed to touch or instruct the robot in a manual way, which is like typing the keyboard or anything. The robot have to be fully autonomous. So the only things that the user able to communicate or able to interface with the robot is by voice mostly. Okay, you can of course other way, for example, use QR code or use other thing, but in a more general and natural way, we use this voice. So in order for you to use voice, which is your synthesis and also recognition, how are you going to make the robot start and stop? So I have written this follower controller, which is you can find in your folder, example folder, that this service control is using another communication way in ROS, which is using the service method rather than the publish subscribe. It is a bit slightly different from the publish subscribe in terms of publish subscribe don't actually need feedback from the other party. But for this service, it requires the other party to request in order for the node to publish or to give certain particular data that the other party need. So it's a bit different. So that's why because I didn't cover this in the class, so I have written this simple example. So you can refer to this simple example. You can read the ROS wiki to understand more about service, how to write service in ROS. But you just need to use this example. You modify like how to control, how to give the signal of start and stop, which is over here. You can use the speech to give the signal. Then you can use this Python code to trigger the follower to start and stop, right? So with these two things integrate into your system, you will able to put your put the follower features into your bigger application. So this is the fundamental things that how we integrate things for application. So this is the first example. So I hope like you can look through this code to understand how they integrate with each other. Right. So, and then we have the next example. Next. Okay, so the next example, which is the example that you can use it after this as your template. If you want to create a general service robot with all the features, for example, like speech, visual, navigation, and so on. So this can act as one of your first template. Of course, it is not a perfect solution. Okay, so I written this in a very simple way to show you how I integrate all these modules together. So I call it a party bot. So it's a robot that you can use it to entertain your guests in a party. Okay, then it will have several functions as I list down there. For example, the first is a speech recognition with LM module to recognize questions from the guests. So that is something that the example that you learn in your class. Then with the understanding of the input from the user by speech, you can use the speech synthesis to speak the answer and play audio file. So that is also the example in the class. And with these two, your robot able to interact verbally with your guests. Okay. Then the third one is take photo by speech command. So which means you ask the robot to take a photo by posting in front of robots, then you will take a photo. So that integrates the visual perception part. Of course, you can not just take a photo, but also do face recognition in order for the robot to understand the guests or to find how many guests in front of the robots and ask them to do something, okay, to move around or to do anything. So I show you this by using the take photo example, which is also available in your class material to show you how I integrate speech and visual together in this application. Then we have the follow, which is the previous example inside here. So you integrated with a follower to start, stop by speech command. So you can ask the robot, follow me, then the robot will start to follow you. You can ask the robot, stop, and then it will stop there. Right. Then, because I didn't put in the navigation part into this example, is because like the navigation part required to build a map and so on. So it is not easy for me to do the demo without the maps and so on. So I didn't integrate the navigation part, but I integrated the moving part, okay, just to show you how to make the robot able to move by dancing. So you have a certain sequence, and also for the arm, because in order for the robots to grab something, so I need to do some pre-learning, which is not convenient for me to do demo in many places, because I don't have the time to pre-train the robots for the environment and also for the object. So I try to replace it with, you can move the arm and move the base for a dancing sequence to show you how the integration is done. But of course, you can modify that part to add in your grabs or to add in your navigation. So they are quite similar. Okay, so these are the features that I put in together. So you can imagine that we have all these things already integrated as a full application. Okay. So let's go to the next, which is David is going to show you a demonstration on this robot. So what David executed will be the list of command that's listed here. But David will tell you more and show you the actual demonstration how this application is being executed. Okay, David, I pass the mic to you.
Okay, thank you, Jeffrey. Can you hear me?
Yes.
Okay, thank you. Now I will introduce how to run the Party Boy, this demonstration for all of us. So first I need to show the environment of the robot. Now the robot is placed in the center of the area of the real world. And we can show you another side of the camera to look at the, sorry, this one, not the robot. This one, we can see the robot from the left side. And now I will change the camera to the global view, and I will show you the command in the real robot. So now I will use the team viewer to connect with the robot and type the commands. First, we need to launch the total bot bring up, which means that we can start the robot. This is the first command, total bot bring up, minimal launch. When the robot is connected with the computer, it will have sound information to tell you it's ready. And then I will launch the arm, robot arm. Oh, a mistake. I will launch again. Okay, we have 5 motors, and each motor has a special name to tell the arm, the waist, the shoulder, the elbow, something like this. And the third one is the follower 2. We use this follower 2 means we have 2 cameras, so we will use topic camera, something like this. We have 2 devices. So we have used the camera at the bottom of the robot to follow the people. And the fourth one is party boy launch. We have specified the DIC and the LM file, which we have discussed in the speech license, how to set up this DIC and MM file to tell the robot which words the robot will know the meaning. So I will change the camera, change the microphone to the camera. So the robot is ready to get performance, the demonstration. So because it has already have the follower command, so the robot will keep the distance from between the robot and me about maybe 20 centimeters, and it will follow something like this. And also can change to the direction where the operator is turning, and I will lead the robot to the position here, and tell it, stop follow.
Okay, I will not follow you.
So you can see in the screen that the terminal, the robot side knows the command stop follow, and it decides I will stop follow you. I will not follow you. And after this command, if I pass the robot in the front of the robot will not move again. So I will show some command here. Introduce yourself.
I heard you want me to introduce myself. I am Party, but I am a party robot to serve you and have fun.
How old are you?
I heard you ask about my age. I am 5 years old.
Okay, now I will lead the robot to the different position in the world. Follow me.
Okay, I will start following you.
The robot will start to follow after he finishes the speech. And if the robot is in the competition, you can tell the robot to something like go to the kitchen or go to the living room. But the position is the point in the navigation map you specified before the running the program. And you can tell the robot to the follow me, and to the gate of the room, and tell the robot pick up the bag and or something like this, and tell the robot go to the kitchen and put down the bag, something like this in the communication. Okay, go back to the start point. Stop follow.
Okay, I will not follow you.
Okay, now I will show you the most interesting demonstration about the robot can dance and sing. Sing and dance.
You want me to sing and dance? Sure, let me show you.
Attending to the arm of the robot, the arm will rise up and something like take the hand, something like this. Okay, that's all. Thank you, Jeffrey.
Okay, thank you, David. Right. Okay, I have the echo. Maybe you need to off your mic. Right, it's okay. Right, so so thanks, David, to show you that is the integrated demonstration. So you can see the robot able to like do everything together. Not to say together, but you actually run all the module parallel. So before the start of the competition, you are supposed to bring up all your speech module, your visual module, your the vision module, and also your navigation module or your movement, the robot movement. So you bring everything up, and then the robot is waiting for your instruction. Okay, so whether you ask the robot to go to certain place, to follow you, to do something, and the robot will, yeah, do accordingly, respond accordingly. So that is what we need for you to develop for this competition, or more general for service robot application. So it's very similar, like just now what you have seen. You can actually change the content into like not just a party robot, but also you can do it, for example, like in the information kiosk. So instead of an information kiosk with statics, or maybe it's not so interesting in terms of attractive, in terms of in a public space. So you can use it, like for example, in hospital, in retail, in supermarket, in mall, and so on, for the robots to entertain your guests in terms of providing information. For example, like you can talk to the robot to say that, please show me which shop. Then the robot will like lead you, bring you there. Or you can ask the robot, please follow me to certain place. Then you can ask the robot to help you. For example, like, please have a look on this product and tell me more about this product, and so on. So a lot of application can be rearranged with this platform and all this functionality you have. So all you need is just to reassemble these features together, and also define the rules. For example, like what are the sentences that the robot need to recognize, and what are the things people, or whether object, or the sequence the robot's supposed to do. So yeah, so with this you can start creating your service robot application. So I hope by now I have shown you a complete example of service robot platform that you can start your development. Okay, so if you have any question, you can ask in the group chat. And I think I have come to the last slide for the first one, right, David? The next one should be no more, right? Can't remember my slide. Okay, yes. So I've completed the first half, which is about the application development. So I will take about 3 minutes break for us to switch the content, and also for you to ask questions. Right. So if you have any question, please ask in the group chat. And also I have some something that to ask you to fill for me. So the first thing is, please fill in the attendance form. So for those that just arrived, so please fill in the attendance form. And over here, I have another survey form, which is, I would appreciate if you can give some feedback to us. Okay, so please spend about 2-3 minutes to fill in this form. Okay, the purpose is I need your attendance. Is in order for us to keep a record that how many have attended our classes. It is very important for us to plan for the next class or the next classroom series, and also to convince RoboCup Federation and also our sponsors that this activities actually benefit the general public. So that's for the attendance. And the second thing for the survey, for the feedback, that is for the reason that we are going to come up with new online classroom series. Particularly, we are going to start the invited lecture series, which is not me, but other professors is going to give you more expert class after this. And we need to improve our arrangement or organization, particularly in the timing, because I need to understand what time is suitable for our audience and what audience prefer what kind of topic and when are they available for the class and so on. So by filling in this survey form will help us to get to know more how to arrange a better class in terms of the content and also in terms of the timing, the logistic thing, so that it can fit your need and also your convenience better. Okay, so with that, please fill in these two forms. One is for the attendance, one is for the feedback. Okay, right. So I will start again maybe in 2-3 minutes for you to fill in this form. Okay, and David, you can switch the slide. Okay, you already have that. Okay, so let's wait for 2 minutes, then we'll start. Okay, for the meantime, if you have question, please use the group chat to communicate with us. Okay, I can answer your question now. Yeah, don't worry if let's say like you want to ask any question that is not related to what I just said, but for the previous classes, yes, you can.